During the Second World War, armies learned very quickly that cotton blankets were a liability. Cotton absorbed moisture, collapsed when wet, and stripped heat from exhausted bodies in cold wind. In Europe, the North Atlantic and the Pacific, troops faced rain, sweat, and condensation every day. Commanders did not abandon blankets out of preference. They abandoned them because men were getting cold injuries while wrapped in what looked like adequate bedding. The solution that emerged was a fibre layer that behaved differently at the microscopic level. It trapped heat even when damp, recovered after compression, and could be layered without losing performance. This material quietly replaced cotton wherever conditions were unforgiving, and it outperformed expectations in the worst environments of the war. This eliminates the tiny air pockets that actually provide insulation. Worse, wet cotton conducts heat away from the body faster than dry air, accelerating heat loss. Field reports from winter campaigns showed that adding more cotton did not solve the problem. The answer was not bulk, it was fibre behaviour. Insulation had to retain loft and warmth even when moisture was unavoidable. The fibre layer that replaced cotton was wool felt and wool pile. Unlike woven wool blankets, these layers were engineered to maximize trapped air. Felted wool consists of interlocked fibres that resist collapse. Wool pile, used in liners and sleeping systems, added depth and resilience. Wool fibres are naturally crimped, creating permanent air spaces that remain even when the material is compressed or damp. Wool also contains lanolin, which repels water at the fibre level while still allowing vapour to pass through. In practice, a thinner wool, felt layer kept soldiers warmer than a heavier cotton blanket under the same conditions. One of the key insights of World War II gear design was placement. The wool fibre layer was not usually exposed. It was sandwiched between outer shells and inner liners. This protected it from wind while allowing it to manage moisture coming from the body. Sleeping systems, jackets and bivouac wraps increasingly used wool felt or pile as the middle layer. Cotton, when used at all, was relegated to outer shells where moisture could evaporate more easily. Modern users can apply this principle by placing moisture-tolerant insulation close to the body and using protective outer layers to block wind. Compression resistance, really made the difference in real-world use. Cotton performs best when fluffed and untouched, but, war does not allow that. Soldiers slept on uneven ground, leaned against walls, and carried their bedding for miles. Cotton compressed and stayed flat. Wool, on the other hand, rebounded. Wool felt recovered its loft after being packed, slept on, or worn repeatedly. This meant insulation performance remained consistent over time. In cold conditions, reliability matters more than theoretical warmth. For practical use today, choosing insulation that resists permanent compression improves warmth over long periods without maintenance. The fibre layer performed when wet, which honestly changed survival outcomes. One of wool's most critical advantages is that it retains insulating value when wet. While no insulation performs optimally when soaked, wool continues to trap air and generate warmth through moisture absorption reactions within the fibre. During World War II, this meant soldiers who could not dry their gear overnight still retained warmth. Cotton offered no such margin. Once wet, it became a liability. This is why wool liners and felt pads were favoured in maritime and amphibious operations, where complete dryness was unrealistic. The layer was modular and adaptable across climates. A wool felt pad could be placed under the body, wrapped around the torso, or used as a liner inside a shelter. This adaptability made it valuable across climates, from cold European winters to damp Pacific nights. Cotton blankets lacked this versatility because their performance dropped sharply outside narrow conditions. For modern survival systems, modular insulation allows adjustment without changing core gear. Maintenance and longevity favoured wool over cotton. Wool fibre layers were easier to maintain in the field. They resisted odour, mould and degradation better than cotton. Even when dirty, wool continued to insulate. This durability mattered in long campaigns where resupply was uncertain. Wool felt pads and liners often lasted entire deployments, while cotton bedding required frequent replacement. Applying this lesson today means choosing materials that tolerate neglect without catastrophic performance loss. This wartime shift explains why wool remains relevant despite modern materials. Synthetic insulation eventually replaced wool in many post-war applications, but the principles learned during World War II remain valid. Insulation must manage moisture, resist compression, and maintain loft under stress. The wool fibre layer outperformed cotton because it worked with the human body and environment rather than against them. It accepted moisture as inevitable and remained functional anyway. This forgotten upgrade was about physics, not comfort. The replacement of cotton blankets with wool fibre layers was not about luxury. It was about survival. Warmth retention meant fewer cold injuries, better sleep, and sustained combat effectiveness. Understanding this shift helps explain why certain materials endured long after the war ended. If this guide added real value to your understanding of World War II field engineering and practical insulation science, subscribe to In the Beginning, share this episode with fellow history enthusiasts, and help preserve knowledge that proved itself when conditions were unforgiving.